Okay, so we can probably get started now. So, hello, welcome everyone. This is the 4th Unity Programming Workshop. We will be continuing with physics. Hooray! Does anyone have any questions before we start?
Do we need anything specifically downloaded?
Yeah, so there in the programming channel, there's a link to a repository you should clone. We're basically going to have a repository to clone every workshop. So kind of before the workshop, you can look in the programming channel, and there should be a repository to clone. Any other questions or problems? All right, so I'll just kind of get started and let y'all get to that. So the first thing I want to talk about that I probably should have talked about last time is FixedUpdate. So in order to talk about FixedUpdate, we need to talk about physics intervals. So in Unity, there's basically 2 different kinds of intervals going on. Normally, the game's going to be running just like kind of linearly. It's going to update the game logic, then it's going to render a frame. Then it's going to update the game logic, then it's going to render a frame. Basically how it's going to go. And then kind of intermittently in between them, you have Unity updating physics. And this it does kind of on a fixed interval, like say every 0.018 seconds, it's going to update the physics. It's going to kind of interrupt that schedule and update physics. So as you can see, there's no real order in which it updates the physics. It's just going to do it whenever it needs to, which is on a fixed interval. So that kind of causes a couple issues when we're trying to manipulate physics on this game logic interval. And as we can see, this causes problems with forces being out of sync if you try to add a force, but like your interval happens twice before the next update and you want to do it every frame, and timing gets out of sync. It kind of becomes a mess when you try to manipulate physics inside of update. So the better way to do it is use a completely different function called FixedUpdate. And so what FixedUpdate is basically just update, but kind of synchronized in the physics interval instead of the normal rendering per frame interval. So we can see in our script here that we have 2 different updates. Oh, that's the start. We have our update, and then we have our fixed update, and they're both just void. You can make it just like, you can even just like rename update to fixed update. It won't really matter. But we see that we're manipulating our rigid body and our velocity and so on inside of our fixed update, and we're getting input inside of our regular update. So yeah, that's kind of how you want to use FixedUpdate. It also has its own delta time, and if you remember, delta time is the way that we convert from units per frame to units per second. FixedUpdate has its time.fixed delta time, so that's going to be the interval at which physics are updated, and you can use it for the same thing. You can use it to do units per second, units per interval into units per second, and so on and so forth. Typically, you don't really need to use fixed delta time because you're setting velocities, but if you're moving something with like rigid body.move position, then you might want to use fixed delta time for that. Does that kind of make sense so far for everyone? Okay. So as you saw, I'm doing my input checking for the player wanting to jump inside of update. And the reason for that is kind of the same thing we want FixedUpdate in the first place, is your input updates every time your behavior updates. It's on the same interval. But FixedUpdate isn't on that interval. So if you are checking for input updates inside of FixedUpdate, you're not really going to be synchronized to your input. So if your fixed update is updating slower than your regular update, then you're going to be missing inputs. So if you press a button down and release it before it can update physics, then it's going to miss that input entirely, and you're not going to get anything, any behavior. So the way to do this is like I've done inside of update. You want to check for your inputs, and then you can use that value inside of fixed update. And so right here I'm setting wants to jump whenever jump is pressed, and then this is only going to update when update is called, and then when I act on it, I set it back to false, so that if fixed update runs twice before update is run, then it's going to have done this piece of code already. Anyone have any questions on how that all works? Okay. So the next thing a lot of people asked was, how do we customize physical properties? If you remember last time, we had a box that was kind of jumping or bouncing, and we got that behavior by applying a force every time it hit the ground. But people wanted to know, how would you have that box kind of lose momentum as it goes? And the way you do that is with properties. So some of the physical properties are attached to the rigid body. So if you just like mouse over the rigid body in the inspector, then you're going to see all these different properties. And the ones we really care about are its mass, linear drag, angular drag, and gravity scale. Gravity scale is kind of, self-explanatory. You multiply that number by the normal gravity, and that's going to be the new gravity applied. So if you wanted half of the gravity to be applied, then you would put 0.5 there. Twice the gravity would be 2, so on and so forth. The mass is going to be affecting how other rigid bodies interact with that rigid body. And so if you have a really heavy object, then pushing it's going to be really difficult. But if you have a really light object, then pushing it's going to be very easy. And then linear and angular drag, or how it flies through the air. Kind of hard to explain those two, so you basically just want to play with those and get the kind of feeling that you want behavior-wise. And you can look at the specific documentation on the Unity documentation. So the other two physical properties that you want to be messing with are friction and bounciness. And these are both held in physics material 2Ds. And so we can look in our project and see that our ground has on its rigid body a material. And that material is our physics material 2D. And we can see that it has two different properties. Friction, which is the coefficient of friction. The more friction, the harder it is to move across slide across the ground, so on and so forth. And then bounciness. So bounciness is basically a number that is going to be multiplied by the amount of energy you have when you hit the ground or when you hit the object. So basically, if your bounciness is 0, you're going to have 100% energy loss, you're not going to bounce. If your bounciness is at 1, then there's going to be no loss of energy, and you're going to bounce forever at the same height, basically, that you started. Anywhere in between those is going to be basically losing that amount of energy. So if it's at like 0.5, you're going to be losing half your energy every bounce. If it's at 0.25, you're going to be losing 75% of your energy, and so on and so forth. So we can, and also if it's greater than 1, it's going to be adding energy, and we can test that right now. So if we set our ground to be at bounciness 1, and we play, then our two rigid bodies are going to start bouncing, and they're going to be bouncing continuously at the same height forever. And I think I can just change this here. If we change this to 0, no, I need to redo this. If I change it to 0, then they're going to hit the ground and not bounce anymore. 0.5, and it's going to bounce a couple times and then kind of go back. So anywhere between 0 and 1 is going to be a good representation of the real world. You can't really have anything have like 0 bounciness unless it's like a fabric. And you can't really have anything have like 100% bounciness because you're going to be losing energy. And then if it's above 1, then that's kind of beyond the physical world. So if we set it to 2, then it's going to be bouncing higher and higher every time. And that's kind of like a trampoline or something. Does that make sense, how these physical properties are kind of done? Anyone have any questions on how you use these? So as we kind of noted, this material is applied to this rigid body. You can also see that a collider can take a physics material. And this is kind of a weird thing, is that like you have 2 different ways of applying this material. And the collider is actually going to be taking precedence over the rigid body. So if we applied a different material to this collider, then it's going to ignore the material on the rigid body, and it's just going to use the material on the collider. The reason for this is, say you have a really complicated level, and it only has one rigid body, and it has a bunch of colliders. And you want those colliders to each have a different material. Say you have like a really bouncy section or a really like rough section that has a lot of friction, then you can apply a different physics material to each one of those colliders, and then have a kind of default material applied to the rigid body. So say you just wanted a default, and you only applied a specific material to things that needed a different material. So if the collider doesn't have a material, it's going to fall back to the rigid body. If it does, it's going to use that collider's material. Yeah?
What happens if you apply the material to the player character?
Well, let's see. So let's just put it on the collider and remove it from there. So now our player has the ground material, and it has a bounciness of 2. So now we can see that only the player is being affected by that, and the other object isn't. It's just kind of sitting there because these two have a different physics material and so on. So yeah, it's applied basically per object. Does that make sense?
What if the player had a physics material and the ground had a different material? How would this interact?
Let's see. So let's create a new physics material and say, let's have this one be the player material and reapply this one to the ground. This collider, player has a different one. So let's set the bounciness to say 0.5 and set the bounciness of the ground to 0.5. So now the player has a bounciness of 0.5, the ground has a bounciness of 0.5, and the box has a bounciness of 0. It kind of took the kind of lowest common denominator. So if we put the player up to 1, see how they interact. So now it's taking the kind of highest bounciness and using that. Otherwise, it's going to take the next highest bounciness. Does that kind of make sense? And we can play around with the friction as well. So if we set the bounciness to 0 and everything, but we should put the material on the enemy now, because the players kind of ignore friction, how I have it set up. Put the player material on the enemy and have it have a very high friction, and then have the friction on the ground be nothing. Then, oh, huh, that's interesting. So the sprite should have a high friction, which it does, but the ground, here, maybe I'm just not doing the friction right. So yeah, so now it's going to take the kind of lowest. So
if the ground has anything other than 0, is it going to just stick?
yeah, so if we set this to 50 and set the players to 0, so for the friction, it's going to take the lowest number. So if we set the player's friction up to 1 and our ground friction is at 50, then should take the lowest one. So now the friction is going to be 1. Yeah. So now,
What does 50 look like?
so let's put the friction to 50 on both of them. It's going to be about the same thing because they're both very high friction. And if we set the enemy to not rotate at all, then we're going to basically not be able to kind of push it. So it can't really be pushed at all since it's such a high friction. Does that kind of make sense? That's also something you can kind of play around with. If that doesn't really make a whole lot of sense, then you can kind of do a lot of tests and kind of see how these interact.
So instead of taking the two frictions and seeing how the two frictions would interact with each other, it just takes the lowest one?
I believe so. I want to make sure of that. It might add them. For the bounciness, it's going to take the
Bouncier one.
yeah, the bouncier one. I will probably do some more research on that and then post it in the programming channel. But for now, yeah, that's how I'm going to say it works. You have anything to add, Wayne?
I think it may try to simulate the physics in real life. So for example, if we have a wooden box which has a higher friction coefficient, and we have ice ground, and we put the wooden box at the ice ground and we push it, it still moves smooth. So that's why even if they have different coefficients, we use the smaller ones.
Yeah.
For the bounce, for example, we put a human on some floors, they are still able to bounce because the board has a higher bounce.
Yeah, okay.
That's the reason here.
Yeah, that makes sense. All right. Any other questions on this? Okay. So that's, yeah. The next topic is raycasting, and raycasting is a very useful tool in Unity and physics. So, does everyone here know kind of the concept of raycasting? So, how many of you heard of the term hit scan in terms of weapons? So, in a lot of FPS games, you're going to be hearing a distinction between hit scan and projectile weapons. Hit scan being it's going to basically just shoot at anything you click on, and then projectile is going to be kind of a physical object moving through the air. That hit scan is done through a raycast. So basically what's happening there is you have a single raycast being cast from the player's position out into just some area, so probably in front of the player. And then anything that it collides with on its way there is going to be hit and returned as a collision. So how we do this in our script is through physics2d.linecast. This is just a simple like Raycast where you have a beginning and an end, and anything in between those 2 points is going to be returned as a hit. So there's a lot of really interesting things you can do with this that's listed in the documentation, but right now we're just going to be kind of using the simplest form of it. So yeah, like I explained, this is kind of how it works. You have a start position, an end position, and anything in between that is going to be returned as a Raycast hit 2D. And so how we can use that in our code is we can make a variable of type Raycast hit 2D, and then we can use our function physics2d.linecast, give it a start and end position, and then if something hits, then we're going to have a Raycast hit 2D inside of our result. If nothing is hit in the Raycast, then it's going to return nothing. The result should be null. So we can kind of use this in our code to kind of determine what like the object is by accessing things like its collider. The full description of what a Raycast hit is in the documentation, and I highly recommend you read it because there's stuff like the point of impact and a bunch of other things about the collider that you can access there. But what we're really going to be interested in is the Raycast hit 2D.collider. And this is the collider of the object that it hit, which we can kind of see in here. It's just going to return this, basically. So what we can do with that is we can access its tag, see if it's an enemy, we can access its rigid body, its game object, so on and so forth. So here I'm getting the collider's game object and setting it to enemy, and from there I can do other things like set its position and so on. Something we often want to do with Raycasts is we want to ignore some things. So something you often do with a Raycast is you cast it from the player outwards. So if you're firing a gun, you want to fire it from like the player in a direction that you're aiming. However, if you do that, then you're often going to be hitting the player's rigid body or the player's collider, and that's not something we want to do. So what I've done here, and this is a common thing you can do, is you can set the player's layer to ignore Raycast. And each object has a layer that it's on. Usually it's going to be on default. And you can set it to ignore Raycast. And any Raycast that passes through the player now is going to be ignored. So this isn't really an optimal solution all the time because sometimes you might want the player to be hit by Raycasts, but not from their own. So something you can do is you can pass, let me see if I can go into this documentation here. You can pass something called a layer mask, which is going to tell the Raycast which layers to ignore. So say you wanted just a player layer, so you would add a player here, go back here, set this to player, and then you would pass the layer mask like an 8. That's not exactly how it works, but basically you would pass it that layer, and it's going to ignore it. That's not something you really need to worry about right now, but later on, that's something you want to look into. set this back to Raycast. Any questions so far on how Raycasts work?
So when you made like the player layer and you're like passing it as a mass, would you just be doing that in your scripts?
Yeah. So
Okay.
so you would pass that. That would be an argument of your linecast.
Okay.
And for any Raycast that you do, you want to look at the documentation and see how that would do that. So by default, it's going to be passing default Raycast layers, and you can pass it a different layer mask.
Okay.
And I believe you and them together. But yeah, that's something you don't really need to worry about right now. That's, yeah. Any other questions? Actually, so linecast isn't the only Raycast function. There are other ones like boxcast, which is going to be like anything in between the edges. There's circlecast, which is intersecting with the circle. Raycast, which is like a more advanced linecast that you can kind of play with. And then capsulecast, which is intersecting with the capsule. Yeah.
All those basically what like hitboxes are, just like a square in space.
Yeah, kind of. Except for hitboxes are going to return anything inside of the hitbox. A raycast is going to return anything that intersects with the raycast. So you have a box defined by 4 edges. If anything intersects the edge, then it's going to return that. If it's inside or outside, it's not going to return. Does that make sense? Okay. So let's go and kind of see how this works. I'm going to remove all the physics materials for now so that we can kind of do this. So inside of my fixed update, I'm going to do linecast functions. So Raycast hit 2D. Our result is physics 2D. Come on. Physics 2D dot linecast. And I'm going to pass it my rigid body's current position as a start. And then I'm going to say its end is my rigid body's position plus a new vector 2. 100, 0. So can anyone tell me the direction that this linecast is going to be casting? So we've got our rigid body's position, and we're adding a new vector 2, 100 in the x direction and 0 in the y direction.
So that way, looking at that screen.
Yes, to the right?
Yes.
Yes. So if we need to kind of do something with the result to see this. So if we say like if result, and this if result is going to return true whenever the result exists, which is if something hits the linecast. So we can say if result, get the results collider, game object, get component, it's rigid body 2D, dot add force, new vector 2, 0, no, 0, 100. Force mode 2D dot impulse. So, can anyone tell me what this stupid one-liner is going to do? Yes.
So it takes the result, it gets the collider from it, it
Mhm.
gets the game object from that,
Mm-hmm.
and then it gets the rigid
Mm-hmm.
And it has a force to that rigid body.
Mm-hmm. Which direction?
Upward.
Upward, yes. So now, if we go ahead and test this, I'm going to put the player above the other rigid body a little bit. Just make sure this is being applied. Yep, right here. So now if we fall, it doesn't work. And that's because, oh, no, that's in ordinary Raycast. I've done something wrong. Wayne, can you see what I've done wrong?
You can try to debug it.
Is it 100 too close?
Well, this isn't, oh, the thing is, I didn't save it. Remember to hit Control S. So
Oh.
now if it comes in contact, then it's gonna go straight up. So, one problem that we just had is we can't see any line casts. They aren't in the physical world, they just kind of exist in math. So to help alleviate this problem, we have debug.drawLine. So, with debug.drawLine, we can have an actual visual representation of our Raycasts. So it basically is the same thing as like linecast. You give it a start, you give it an end, and then optionally it takes a color and a duration. So what we can do here is right next to our linecast function, we can say debug.drawLine, our rigid body position, rb.position plus new vector 2, 100, 0, color dot yellow, and no duration. So now I'm going to put this up a little bit more so we can see it. So now if we play, go into the editor view, we can see there's a line coming out from the player. And this line represents our ray. So this ray is going from the player's position to 100 units to the right. However, if we go into the game view, it's not appearing in the game view. And that is by design because our debug functions only really affect the editor. So our debug dot print line? Yeah. So yeah, our debug dot draw line is only going to be affecting our actual editor window, which is you can get to it from the game by just like this, and you have to kind of click back in. Our print function only affected our console, which is in the editor, and so yeah, all of our debug functions only affect the editor. Questions on that? So if you're actually looking for something that does draw a line in the game, there's a much more fully featured component called line renderer that we can like actually add to like the player. And we can see it's got like all this like stuff that we can control in the script, and we can turn it off and on and so on and so forth. That would be what you want to use if you want the line to appear in the game. But for just debug purposes, it's totally fine to just use debug.drawLine. So yeah, you might have noticed that we kind of like have just like a lot of things here that we can play with. We have a player controller that you can kind of control. And what I want you to do is kind of just play around with all of these things in the scene. Kind of scrutinize what I did in the script. There's like a lot that I did here that you might just like be scratching your head at. So like, you know, Why is this not inside of is touching ground? What is touching ground even do? What if this was different? What if we set this to 0? You know, so on and so forth. So yeah, you can go ahead and just like play around with all the physics stuff in the scene. Otherwise, your challenge is to change the enemy's color with a raycast. Does that make sense? And if you are like confused about anything or want me to like demonstrate something, just ask and I can like do it in my project. Cool. I'm gonna put the script up, and also the slides are in the programming channel if you want to reference something. And yeah. Cool. Collapse this. Yes. Collapse this. Real quick, I'm going to stop the stream.